Hi, students. Today we're going to learn about the commutative property. Okay, so to commute, what does commute mean? Commute means to move. Okay, so we're going to be moving some numbers, but we're not going to change the answers. So the commutative property, it applies to addition. Okay, it applies to two different things. It applies to addition. And in addition, the add-ins, the numbers that you're adding, they can exchange places, so they can switch places and still equal the same sum, the same answer. So if you look at this example, 7 plus 2 equals 2 plus 7, because even if I switch the numbers around, the answer is still going to be 9. Okay, so 7 plus 2 is 9. 2 plus 7 is still 9. Okay, so it works for addition. Commutative property of addition means I'm switching the numbers, but the answer is still the same. Now, it also works for multiplication. So I can switch the numbers in multiplication, and it's still the same. The factors can exchange places and still equal the same product. So like this example, 3 times 2, well, that's 6. But 2 times 3, that's still 6. So I still get the same answer. So commutative property is when I switch the numbers and the answer is still the same. And it only works for addition and multiplication. So let's look at some practice questions. So here, what property is shown here? Okay, we know it's going to be commutative because all they're doing is switching the numbers. We're switching 34, 27, 27, 34. All I did was flip-flop them. Well, is it commutative property of addition or multiplication? Well, it's addition because the problem is addition problem. So answer, it's the commutative property of addition. Okay, well, what about this one? Commutative, what did they do? They switched the numbers, 66 times 37 or 37 times 66, same thing. And the star also means multiplication, so this is commutative property of multiplication. Okay. Now, which shows the commutative property of addition? So first off, I'm looking for addition. Well, all of these have addition, okay? Commutative, remember, I'm switching the numbers around. So let's take a look. A, 7, 2, 3. Well, this is 3, 7, 8. That's wrong because they have a totally different number right there. B has parentheses. Did I even talk about parentheses? No, I didn't. Okay, C, 7, 2, 3, 2, 3, 7. That looks pretty close, okay? So let's look at D, 7, 2, 3, and then 5, 7, 2. They have a totally different number right there. So it looks like our correct answer is C because all they did, remember, commutative. I'm commuting, I'm changing the numbers around, okay? But the answer stays the same. It's the same numbers, they're just moved around. Okay, so I'm looking for commutative property of multiplication, which shows the commutative property of multiplication. So the same numbers, but just moved around. So A, 7, 8, 4, 7, 16, 2, that's wrong because I've got totally different numbers. B has parentheses, probably not right, because I didn't talk about parentheses. 7, 8, 4, 8, 4, 7. That looks maybe right. And then D also has parentheses. We didn't talk about parentheses. So let's see if we're right. Yep, C, 7, 8, 4, and 8, 4, 7. All they did was mix up the numbers. But remember, it has to be all multiplication or all addition, okay? You can't mix them up and do addition and multiplication in the same problem. So let's get out of this and let's do some other examples. So another example of commutative property is if I had 2 plus x, that's the same thing as x plus 2. Because remember our x is our variable. It's just a letter that stands for a blank that we don't know. We don't know what that number is yet. So it's a blank. But did I change it? No, it's still x. And that's still plus 2. All I did was I flip-flopped it. What if I did x squared plus 4 and then 4 plus x squared? Well, there's still 4. It's still plus 4. And x squared, it's still x squared. So they're still the same. It's just switched around. So that's commutative, okay? Commutative. Okay, commutative. So let's do another one. What if I did 3 times y? Okay, 3 times y. Well, what would be a commutative of that? Well, y times 3. Okay, all I did was switch it around. Now, what if I had 2 plus x plus z? Okay. An example of commutative for that would be maybe x plus 2 plus z. I could even say z plus 2 plus x. That would even be commutative because all I'm doing is I'm switching the numbers around. Okay, but remember, it has to stay multiplication or it has to be all addition. Okay, it's all multiplication or all addition for commutative. So let's go back to here. So commutative property, addition and multiplication, it really doesn't matter which one it is. The numbers exchange, that's the most important part. The numbers exchange places, but it still equals the same, okay? That's the key thing about commutative. The numbers switch places, but it's still the same, and it's all addition or all multiplication, okay? That's commutative property.